Hello, my name is Gunter Weser from GWJ Technology Germany. Today I would like to present you our CAD integration for Solid Edge of our calculation software eAssistant or TBK. The TBK is a calculation software for machine elements, so you can calculate shafts, bearings, shafts and hub connections, and gears. Gears is a very large part of this. And the eAssistant is the web-based solution or the online solution of the TBK. Both works very identical with the CAD integration. So today I would like to show you this with the TBK, but it works also in a very similar way with the eAssistant. So at first I go to the Solid Edge area. And here now I'm in the Solid Edge part area. If I have installed our CAD plugin, I have an integrated menu in the menu bar of the Solid Edge. And here I find the TBK menu bar, because now I want to show this with the TBK. If you have installed this for the eAssistant, you have here the name eAssistant instead of the TBK, and you have to insert your username and password for your eAssistant account, and all other works in the same way like that I show you now with the TBK. With the integrated menu of the TBK in Solid Edge, I can start all different calculation modules, single calculation modules, from the TBK directly out of Solid Edge. So for this I can go to the calculation, and here I can call the shaft calculation, bearing calculation, or gears calculation. So for example, I will start with the cylindrical gear pair calculation. And now the program starts automatically the TBK and also the cylindrical gear pair calculation. And now I'm in the cylindrical gear pair calculation of a TBK, and I can change here some values. For example, I will show you this on a single helical gearing. So I input here a helical angle of 12 degrees, for example. And so the direction of the helix angle is now left for gear 1, and the mating gears automatically correct set by the software. For the normal module, I can input here some different values, also not standard normal modules like 5.1234, for example, or I can click on the unit and I can input also diametrical pitch or circular pitch or something like this. Okay, I take 5 now, and now the program calculates automatically the standard center distance, and if I want to set the working center distance equal to the standard center distance, I can input here 0, and the program set it to this value. But in this example, I would like to work with a little bit larger working center distance, and so we have a splitting of a profile shift here, and number of teeth and face width, for example, 50 and 50. And you can change the splitting of a profile shift by your own, for example, or you have here different options to do this. Yeah, the load capacity and all other are also included. So you have a full professional calculation software according to different standards for cylindrical gear pairs. So in the load capacity calculation, we support, for example, the DIN standard, the ISO standard, or the NCH GME standard, and also next time the VDI guideline for plastic gears, for example. Yeah. But at the moment we are concentrated on the geometry to show the interaction with the CAD program. And now if I input here my values, I can change this also a little bit like this. And I can input also an internal diameter like this, and I set it to 30, and I have some other options. And now I can go to the two-form geometry. in the detail view, and here I can select the tolerance that I want to, with which tolerance I want to work for the modeling in the CAD system. So with the mean two thickness allowances, for example, or with the smallest or largest value, for example. Same is also possible for tip diameter or outside diameter allowances. So before I use the CAD export, I set here my wished tolerance values here. And after this, I can go to the CAD button here, and I can select Solid Edge Export. And now the program calculates and writes this in a transition file with all the data from the calculation, including the two-form geometry coming from the hopping or gear shaping manufacturing process. And after this, I can go back to my Solid Edge. And here I'm now in the synchronous part. It's supported, but I can do this also in the ordered part. It's also possible. At the moment, I will show you this in the synchronous part, only for the generation. So I say now, new part, cylindrical gears, cylindrical gear 1, for example. And the program calculates automatically the gear according to the current calculation that we have done. Yeah. Also with the exact two form here via splines, and so you have a very fast and very good model for this. This is very realistic. Or you can use this also for manufacturing without lengthwise drawing, so you can use this geometry for ADM wiring or laser cutting or something like this, of course. It's very has a very high grade of accuracy. In the synchronous part, I'm a little bit limited, so I have no bidirectional functionality, but I can switch with a new part to the ordered system. So for this I go to new isometric part, and now I switch to ordered mode, and now I can generate the same gear again. So I say new part, cylindrical gears, cylindrical gear 1, for example, and now the program generates this, and I see here also the feature directly from the Solid Edge. And after this, I can call the calculation again, so I will close my calculation, and now I can call the calculation that is based on this gear. So I say calculation gear cylindrical gear pair. The program is detected the calculation information in the gear in the 3D model, and I say yes, please open this and load this information. And now the program opens automatically again the TBK and the cylindrical gear pair calculation module, and now we have our current calculation back. And now I can change something like the number of teeth, the faces like this for both, and a larger helical angle like this, and I change the working center distance. And now I check the two form. I see it's a little bit tapered here. I reduce the tip a little bit. So I go to this. Yeah, this should be work. That's fine. And now, yeah, I go back to the two form detail view. I select here the two thickness allowances, the mean values, go to the CAD, the Solid Edge export. Okay, I go back in the Solid Edge area, and now I select the cutout feature for the two form geometry, and I say now new part, cylindrical gear 1. And now the program asks me, do you want to update the current model on the basis of the current calculation? Yes. And so it's still the same part, but now with the current calculation values. Yeah, that's very easy possible. So You can this works fine for external gears, so you can adjust the phase with a number of T for profile, shift coefficient, and so on, and also the direction of the helix. But you cannot switch to an internal gearing for this. You need a different model for this. Yeah. But you can work also with internal gears. This is very easy possible. So I go back here a little bit. And I say here now minus 66, for example, with minus for the number of T for gear 2. I say the program it's now an internal gearing, and I adjust a little bit the working center distance again. And profile shift, and now I go back to the two-form geometry. Now I see this is an internal gearing now here. And I can work also with a tool, with a gear shaper cutter, for example, like this. And now I will see this also here. The two-form geometry, I select my two-form, I say here, solid edge export. And now I go back and I say now, new part, cylindrical gear 2. And the program generates now the internal gearing. Yeah, very fast. And now you can save this, or you can make a 2D drawing, or we switch directly to a 2D drawing like this. So we say here new isometric draft, for example. And now we can set also the manufacturing data table directly on the drawing. This is also possible. For this we go in our integrated menu of the TBK, and we say here manufacturing data from the selected view or from the current calculation. And so we say for the cylindrical gear 2, for example, and now the program wants to know the insert point. Okay. And now the program generates directly here the manufacturing data table with all important values. This table is also configurable, very easy with a configuration file, and so everybody can adjust this by their own, and so it's very, very easy. Yeah. Okay. So we see this for simple cylindrical gears, and we can cut a gearing also in an existing file. This is also possible. For this, I will open a new part, and for this I generate. I go to the ordered, of course. And for this I would like to generate a shaft. So I close the TBK, or I switch directly to the shaft. This is also possible. And I can model this shaft geometry also directly in the solid edge, but I'm a little bit lazy, so I do this via our calculation. And so I use here an example, and this is just only the geometry. I can insert also a hollow segment. This is also possible, and I can set also gears and notch effects on the shaft. But this is not the topic today, so I use only the geometry for the CAD. So I go to solid edge export again, and now I go here to the new part and shaft, and now we have here the shaft geometry coming from the calculation, or is done by your own manually in the solid edge, of course. And now I can create a new plane, new reference plane, for example, on this face. I need this to cut the gearing in this shaft segment here. And now I go back in the gear calculation, call the cylindrical gear pair calculation, open my example for this. And now it's important that we have here the correct tip diameter or outside diameter. This must be the same like the diameter of a shaft segment where we want to cut in the tooth form. And here we go to the tooth form, detail view, mean tooth thickness allowances, go to the CAD, solid edge export, and go back. And now I can select here this reference plane, and I go to the TBK and I say now new part, cylindrical gear 1. And the program asks for runout. No, I don't want to do this now. And now it's directly cut it in this existing part. This is also possible also for splines, for involute splines, for example. So I set here also a new plane and call here the connections involute splines. We have here different standards available, of course. And I want to open my example. The tooth form, so we have a involute spline here, detail view, okay. And now we go to the solid edge export again, okay. And we select this reference plane and say again TBK, new part, cylindrical gear, connections and involute splines shaft. And now we use the runout, for example, with a radius of 30 millimeters, okay. And now it's done also with a runout here, yeah, of course. And for this we can generate also the manufacturing table on the drawing. It works in the same way like for the cylindrical gears, and we support also bevel gears, straight bevel gears, helical bevel gears, or spiral bevel gears. This is also possible. So if we call, for a short example, a spiral bevel gear pair, we can select here the type of bevel gears. We support for the 3D cut output at the moment the cyclopolyoid, and here we can input some number of teeth, for example, and the reference cone diameter, and here recommended values of face width. We use this and these other values, okay. We go to the tool and we select here, for example, a Klingenberg machine. The red machine is not possible for the current configuration, and here we use this cutter radius, for example, or this, and we go to the geometry. We can input here also a profile shift coefficient like this, or tooth thickness modification factor, and so on. But I don't want to go at the moment too deep in this calculation to show you also with a focus on the CAD integration. For this I need also the gear body dimensions to generate the 3D model. And here I can input the testicular diameter to find the maximum value. I can input 999, enter, and the program set it to the maximum. And here in the same way. Yeah, and here I can input also a hole. This is also possible, and then a distance and so on. And that's okay. And for the tolerances, we can select also a backlash. But this should be enough, and now we can go to the CAD, the solid edge export, and now the program calculates the tooth form, and now we can generate this directly in solid edge. For this I say here new, and new isometric part, and we ordered. And we go to the TBK and we say now new part, bevel gears, bevel gear 1, for example. Okay. And the program generates this, and we can say again bevel gears, bevel gear 2. And the program generates also the large gear for this. This takes a little bit more time. Okay, it's finished because we have some more teeth here, of course, yeah. And we can use also again the manufacturing table, so we can go again to a drawing, for example, here, and we can say manufacturing data from a current calculation for bevel gear 1, for example, and set it on this corner, and now we have this here directly with the main values that you need also for a bevel gear pair. Yeah. Okay, so this should be a short overview of this, approximately to 90% what is possible with the CAD integration of a TBK or eAssistant in the Solid Edge. So I hope it was possible for me to give you a short overview over the possibilities. And you can test this, of course. You can register for a test account for the eAssistant on our eAssistant website. You can download also the CAD plugin from our website, and you can try it by your own. Or if you have some questions, you can contact us at gwj.de or info@gwj.de. This is also possible. Yes, you're really welcome with your feedback and questions, and thank you for your time today. Bye bye.